Okay, so this is our review video for the quiz 1. Okay, for the quiz 1. So the first topic is the simplified difference quotient, right? Difference quotient. So what is difference quotient? So here's the definition, right? So it's f of x plus h minus f of x divided by h, right? Divided by h. So now let's look at our first example, right? First example. So f of x is x squared plus 3x plus 2, right? Plus 2. So to find quotient, different quotient, we first find f of x plus h. So this is x plus h squared plus 3x plus h plus 2, right? Plus 2. So here we have a box, and then x plus h is in the box, right? Is in the box. Okay? Yeah. So now you need to simplify this a little bit. So be careful. So what is x plus h squared? X plus h squared is x plus h times x plus h. So use for your method, you can check it. It's x squared plus xh plus xh plus h squared. And then you can get x squared plus 2xh plus h squared. Okay? Plus h squared. Okay, so it's not x squared plus h squared, right? Plus h squared. So we got f of x plus h. This is x squared plus 2xh plus h squared plus, so now 3 times x, 3 times h distribution. 3x plus 3h plus 2, right? Plus 2. So now we can simplify the difference quotient, right? And remember, every term without h will be cancelled. And then divided by h is divisible, right? Divisible. So f of x plus h minus f of x divided by h. So this is x squared plus 2xh plus h squared plus 3x plus 3h plus 2. And then minus f of x, you just copy the formula of f of x, right? Minus x squared plus 3x plus 2, right? And then the terms without h will be cancelled, so x squared cancelled, 3x cancelled, 2 cancelled, and then divided by h, right? Divided by h. So this is 2xh plus h squared plus 3h divided by h, right? These three terms stay there on top. So divided by h, so then we got 2x plus h plus 3, okay? Plus 3. So that's our first example, right? First example. So you first find what is f of x plus h, and then cancel the terms without h on the numerator, okay? On the numerator. Okay, yeah, so I will leave the second example as class exercise. So I'm not going to do it now. So let's jump to the third example, right? The third example. So f of x is 1 over 2x, right? 1 over 2x. So now what is f of x plus h? So this is 1 over 2 times x plus h, right? 2 times x plus h. Okay, yeah. Then our quotient, so f of x plus h minus f of x, then this will be 1 over 2x plus h minus 1 over 2x, right? 2x. So now this case, we need a common denominator, right? Because subtraction, we don't have like fractions, we need a common denominator, right? We need a common denominator. So what's the common denominator? Common denominator is 2x plus h times x, right? Times x. So the first fraction multiplied by x, second fraction multiplied by x plus h, then you get the common denominator, right? Common denominator. So now what's on top? On top we got x times 1 minus 1 times x plus h. So this is negative h over 2x plus h times h. Okay, so this is x plus h minus f of x is not the quotient, right? Not quotient. We have to divide by h, right? Divide by h. So f of x plus h minus f of x divided by h is this result divided by h. Times x divided by h, right? Divided by h. So now h cancelled. So this will be -1 over 2 times x plus h times x, okay, times x. So if you're not familiar with fractions, if you're not familiar with this, so you can think this is multiplication, right? So it's negative h over 2x plus h times x. So divided by h. So divided by h change to multiply 1 over h, right? And then you can see h cancelled. Then we got -1 over 2x plus h times h. Okay, times h. So this is a harder case, right? This is a harder case. So that's our first topic. So basically, you first find out what is f of x plus h, and then simplify this difference on top, and then divide by h. Okay, and then divide by h. Okay, so the next question is even or odd function. Okay, so what's the even function? So if f of x is equal to f of negative x, that implies f of x is even. Okay, so if f of x is equal to negative of f of negative x, that implies f of x is odd. Otherwise, it's neither even or not odd, right? Okay, yeah. So for this kind of question, you just need to check what is f of negative x, what is f of negative x. So if you get f of x back, then it's even or odd, right? Even or odd. Okay, so now first question. F of x is 5x minus 2, right? So what is f of negative x? So this is 5 times negative x minus 2. So this is negative 5x minus 2, which is not f of x. So this is not even, right? Not even. Okay, so f of x negative, f of negative x done. So now we check negative f of x, right? Check the odd part. So negative f of negative x. So if this is equal to f of x, then it's odd function, right? Odd function. So this is negative f of negative x minus 2. So this is negative 5x minus 2. So this is 5x plus 2. Right? F of x is 5x minus 2. So this is also not equal to f of x. So this is not odd. Right? So example 1 is not even, not odd. So it's neither, right? It's neither. Okay, so this is our example 2, which is 2x cubed plus 3x, right? Plus 3x. So again, we check f of negative x and negative f of negative x, right? Yeah. So this is 2 negative x cubed plus 3 negative x. So this is negative 2x cubed minus 3x. So this is not f of x, and it's not even, right? Not even. Okay, and then after practice, you will see this negative sign, just change the sign of f of negative x. So you don't have to do the substitution again. You just change the sign here for this function, you got the next one, right? You got the next one. So this will be negative, and then negative 2x cubed minus 3x. So this is positive 2x cubed plus 3x. So this is exactly equal to f of x, right? F of x. So negative f of negative x is equal to f of x. That is an odd function, right? That is odd function. So first one is neither, and then this one is odd, right? It's odd. Okay, so now this question is the transformations, right? We move pictures to get a new picture. And I think this is also our homework question, homework picture. So maybe the functions are different, movements are different, but the graph is the homework one, right? Homework one. Okay, so now let's look at the first one. So f of x minus 3, right? Minus 3. So we are looking at a, f b of x minus h, and then plus k, right? Plus k. Okay, so now this 3 means k is negative 3, right? K is negative 3. So k is negative 3. We know we should move down 3 units, right? Move down 3 units. Okay, so the whole picture moved down 3 units, right? So now how can you move the picture down 3 units? So at this point 2, 2, move down 3 units, you got negative 1, 2, right here. Okay, and then 4, 0, move down, so 2, 2, move down 3 units, you got 2, negative 1, 2, negative 1, right? And at this point 4, 0, move down 3 units, you got 4, negative 3, right? Negative 3. So we got 4, negative 3 is here, right? And then 0, 0, you move these special 5 points, and then you got the answer, right? You got the answer. 0, 0, move to 0, negative 3, and then negative 2, 2, move to negative 2, negative 5, and then the last point move to here. So this is our picture, right? This is our picture. Okay, for that question, move down 3 units, right? Move down 3 units. Okay, so these special point, turning points, end points are the important points. You figure out where all those points go, you got the answer, right? You got the answer. Okay, so now let's look at the next one, right? The next one. So the next one, h is negative 2, so that means we move to the left 2 units, right? 2 units. The whole picture moved to the left, right? So now where is 2, 2 goes? So 2, 2, move to the left, you got 0, 2, right? So that's the 2, 2, move to the left, you got 0, 2, so move to here, and then 4, 0, move to the left 2, you got 2, 0, right? You got 2, 0. Right, so again, these endpoints are turning point, right? Turning point. So 0, 0 go to negative 2, and then negative 4 goes to negative 6, and then this negative 2 goes to negative 4, right? So we got this picture. Right, the whole picture moved to the left 2 units, okay? 2 units. Okay, so the next two are reflection, right? The next two are reflections. Okay, so the first one is outside the function, so that means we reflect this way, right? We reflect vertically, right? Vertically. And then this is inside, so we reflect this way, right? Okay, and again, we want to see where the special point goes, right? Reflect vertically, so this point will go up to there, right? So negative 2, negative 2, reflect vertically, it goes to negative 2, 2, right? And then 2, 2, reflect vertically, it goes down to there, so it's 2, negative 2. Okay, reflect vertically means x doesn't change, y change to opposite, right? Y change to opposite. Okay, yeah. So now we get the new picture, and then these 3 points on the x-axis, it doesn't move, right? Doesn't move. Okay, so this is reflect vertically, right? Reflect vertical. So for this special picture, reflect horizontally, we'll get the same picture. Okay, same picture, but the points are different, right? The points different. Okay, so let's label A, B, and C. These 3 points A, B, and C. So vertical reflection, so we change point A to point B. Okay, so horizontal reflection, we will change point C to point B, right? So point C is 2, 2. And then horizontal reflection is change the x part, you got the point B, right? You got point B. Okay, yeah. And then horizontal reflection, we will change A to D, right? A to D. So negative 2, negative 2. So this is point A. So horizontal reflection, you change negative 2 to x equal to 2. So we got 2, negative 2. So this is point D. Okay, point D. So it's A goes to D, C goes to B, and then we got the same picture. Okay, and on the x-axis is not doesn't move on the x-axis. So this negative 4 point F goes to point 4 E. Okay, yeah. So that point F goes to point E goes to point F. Only the center 0, 0 doesn't move. Okay, doesn't move, and you get the same picture. Okay, got the same picture, but it's changing differently, right? So let me label this. This is C, this is D. Okay? Yeah. So vertical reflection is A to B, C to D. Horizontal reflection is C to B, A to D, and F to E. Okay? Yeah. Okay, so this is the reflection. So now what's the last one? What's the last one? Last one is a little bit harder. So the last one has a reflection, right? This is a vertical reflection. And we have to move it to the left 2 units. Right? 2 units. Okay? Yeah. So we combine these two, right? We combine these two. Okay, move to the left and then reflect. Okay, and then reflect. So we already did these two parts separately. So now I will just draw the picture, right? Draw the picture. So move to the left 2 units. Then we got this picture. Right, the blue curve move to the left 2. You got this red curve, red curve. So now I'm going to reflect. So I will draw the blue curve again, right? I will use the blue curve again. So this will go up, and then this up will go down. Okay, yeah. So let's make it thicker or darker. Okay, yeah. So that's the result, right? That's the result. Maybe I can use green color to make it green. Okay, yeah. So move to the left and then reflect. Okay, and then reflect. So that's the graph part. Okay, that's the graph part. Okay, so now the next part is the domain of the function. So we need to check 2 conditions, right? First condition, denominator is not 0. Second condition, you are taking square root of non-negative number. So which means greater than or equal to 0, right? Radicand is greater than or equal to 0. Okay? Yeah. So now question 1. F of x is 5x minus 2 over x squared minus 2x. So now we have denominator, no radicals. So for the domain, we need this is not equal to 0, right? So x squared minus 2x is not equal to 0. So you have to solve these quadratic function. You can use quadratic formula or whatever method you have. The faster method is factoring x times x minus 2, right? Is not equal to 0. So x is not 0, and x minus 2 is not 0. So x is not 0, and x minus 2 is not 0 means plus 2 plus 2, x is not 2, right? It's not 2. So the domain of f is x is not 0 and x is not 2. Okay, so you only need to check the first condition because there's no radical sign, right? No radical sign. Okay, yeah. Okay, so example 2 is 3x minus 2 in the radical sign, right? In the radical sign, then you need to check this is greater than or equal to 0, right? Greater than or equal to 0. Okay, yeah. So 3x minus 2 greater than or equal to 0. Then we have 3x plus 2 plus 2 is greater than or equal to 2 divided by 3. You got x is greater than or equal to 2/3, right? 2/3. So this is the domain. Right, this is the domain. And for some harder question, we need to check both conditions, right? Both conditions. So if they said, okay, g of x is radical 3x minus 2 over x minus 2, right? Then you have to check, make sure. So first, this one greater than or equal to 0, and then this is not 0, right? So we got x is greater than or equal to 2/3, and x cannot be 2. So this will be the domain. Okay, this will be the domain. Okay, so that's the domain. So now let's look at the basic operations of functions. Okay, so you are given 2 functions. F of x is x squared minus x. G of x is 2x. So first is write down their division, right? Their division. So this is f of x over g of x. So this is x squared minus x divided by 2x. Okay, 2x. So that's a very easy one, right? That's a very easy one. So second one is f plus g of negative 2. So this means f of -2 plus g of -2. Just do them separately, right? Do them separately. So what is f of -2? This is -2 squared minus -2, so which is 4 plus 2, 6. G of -2, this is 2 times -2, which is -4, right? -4. Then we got 6 plus -4, 2, right? 2. And the last one is similar. I have g 3, so this means f of 3 times g of 3, right? So f of 3, we got 3 squared minus 3, so this is 6, 9 minus 3. G of 3 is 2 times 3 is also 6, so this is 6 times 6, 36. Okay, 36. So basic operations is easy. So now let's look at composition. Well, let's look at composition. Okay, so f of x is x squared minus 3, g of x is 2x. So first let's look at f compose g of x, right? So this is x first, and then you apply g, and then you got a box, and then you apply f, right? F. So what is g? G is 2x, so we got 2x in the box. So what is f of 2x? So this is box squared minus 3, and you have 2x in here. Right, so if you like, you can simplify this a little bit. This is 2x squared minus 3, so which is 4x squared minus 3. Okay, 3. So you can also use the definition. F compose g of x. So this is f of g of x. So this is f of 2x. And then you got the same calculation. 2x squared minus 3, which is 4x squared minus 3. Okay, minus 3. So that's example 1, right? That's example 1. Okay, so example 2 is g compose g of x, right? So this means x and then g. You got a box output of g, and you use g again, right? G again. So now what is g? G is double the x, so this is double the box, right? Double the box. So 2x times 2, you got 4x, right? 4x. So if you use the definition, this will be g of x. So this gx give you 2x, you got g of 2x, and then you got 2 times 2x, which is 4x. Okay, 4x. So same result, two different way to write it down, right? Two different way to write it down. And number 3 is composition, and then you give a number, right? You give a number. So g compose f of 3. So now this time you apply f first to number 3, and then whatever number you got, you apply g, right? Apply g. So f of 3, so this is 3 squared minus 3. So you got 9 minus 3, 6, and then g of 6, this is 2 times the box. So 2 times 6, you got 12, right? So this is 12, okay? This is 12. So composition is also not hard, right? It's also not hard. Okay, so for the inverse function, so we got first, so check f of x is 5x, and the g of x is x over 5. They are inverse of each other. Okay, check it. So you need to check two conditions, right? So f compose g of x has to equal to x, and g compose f of x has to equal to x. If they're not equal to x, then it's wrong, right? It's not inverse function, right? So this is the picture. X, f send it to f of x, and then g send it back, right? G send it back. So f compose g, or g compose f. The other way, you will always get x back, yeah, x back. Okay, so now let's use composition arrows to check it, whether we got x back, right? So start from x, so you apply g, and you apply f, you want to get x, and then the other one, you apply f, and then you apply g, you want to get x, right? You want to get x. Okay, so now what is f do? F here is 5 times the box. What did g do? G is box over 5, right? Box over 5. Okay, so now x first g, then we got x over 5, and then 5 times x over 5, so it's 5 times x over 5, 5 cancelled, we got x. So good, right? Good. So first I apply f, so x goes to 5x, and then we apply g, so we got 5x over 5. So 5x over 5 also cancelled, we got x back. So good again, so they are inverse of each other, right? So f and g are inverse of each other. Okay, so that's given two functions. You use compositions to check whether they are the inverse of each other, right? Inverse of each other. So now if you're only given one function, how to find f inverse, right? How to find f inverse. So let's say f of x is 2x plus minus 7. Okay, so we have 3 steps to find the inverse function, right? Step 1, essentially just change left variables, right? Yeah. So this is the idea. X change to f, y is f of x, and f inverse change y back to x, right? Back to x. So first change f of x to y. So we got y is 2x minus 7. Step 2, solve for x. So we got y is 2x minus 7 plus 7 plus 7. Then we got y plus 7 is 2x divided by 2 divided by 2. We got x is y plus 7 over 2. And then step 3, change x to f inverse y. Right, so we got y plus 7 over 2 is f inverse y. Okay, so step 1, change f of x to y, change notation. Step 3, change x to f inverse of y, change notation. So there's no calculation in the beginning and the end, only in the middle, solve for x. Okay, solve for x. So it's also easy, but you have to remember what to do, right? You remember what to do. Okay, yeah, so let me draw this understanding for inverse again. X to y, so this is f, and then f inverse, send y to back to x, right? Back to x. Okay, yeah. Okay, so now we are talking about the graph again, but this time we will talk about domain range, intercepts, increasing, decreasing, and special points on the graph, right? So let's do it slowly, right? Let's do it slowly. Okay, so first the domain of f, so we will project all the functions to the x-axis, right? So we project this here, and then this there, so this will be the domain of f, right? Domain of f, so it's from -2 to +6, right? +6. Okay, so that's the domain of f. So in the domain of g, we do the same thing, right? We project everything to the x-axis, but this is arrow continue, continue, so that means continue forever, right? Then when you project everything to x-axis, you imagine you push everything, project everything to the x-axis, you got the whole x-axis, right? So the domain of g is -infinity to +infinity. So domain is on the x-axis. Okay, so now for the range, right, we will project everything to the y-axis, right? Yeah, for the range of f, so we go here, we go this way, right? We push everything to the y-axis. So you see the maximum is 6, minimum is 2 for f, right? So the range for f, but this should be closed, sorry. So it's still -2 to 6, but this is on y-axis now, right? On y-axis now. Okay, and then range for g, so we push everything to the y-axis. So again, the going down forever, so you got the whole negative y-axis, right? So it's -infinity to 0 and 0 closed. Okay, 0 closed. So that's the domain and range. Domain on x-axis, and the range on y-axis. Okay, range on y-axis. Okay, so now x-intercept and y-intercept. So x-intercept, y-intercept are where these points touch x and y-axis, right? So this is x-intercept for f, this is x-intercept for f, and then y-intercept for g, and y-intercept for g, right? So x-intercept for f is 4, 0. X-intercept for g, you get 2 intercepts, 0, 0, and 3, 0. y-intercept of f, so this is 0, 4, and then y-intercept of g is 0, 0. Okay, it's 0, 0. Okay, you just look at where the graph touch x or y-axis. So now increasing and decreasing. So the whole line of f is going down, so there's no increasing, right? So this is none. So decreasing on the whole domain. Okay, so increasing or decreasing is talking about the domain. Okay, on the part of the domain. So where x is decreasing the whole domain, so we got -2 to 6. Okay, so on the whole domain here, f is decreasing. Okay, decreasing. Okay, so now for g, this is more interesting, right? For g, this is more interesting. So where g is increasing, so this is increasing, going up, and this is increasing. Right, this is increasing. So first increasing part is -infinity to 0, this part. And the second infinity part is midpoint of 1, 2, right? You project here. This is middle point of 1, 2, so it's 1.5 to 3. So they are increasing, right? They are increasing. So it's -infinity to 0 and 1.5 to 3. Okay, 1.5 to 3. So now where is decreasing? Decreasing is going down, so it's from 0 to 1.5. This is decreasing, this is decreasing. Right, the curve is going down. So here again is 1.5, so from 0 to 1.5 on the x-axis, on the domain, right? That's decreasing. And after 3 is decreasing, right? After 3 is decreasing. So 0, 1.5, and 3 to positive infinity, right? 3 to positive infinity. So for increasing, decreasing, you have to look at the graph and then look at on which part of the domain or x-axis, increasing or decreasing. Okay, so now this is f times g3, right? So this means f of 3 times g of 3, right? G of 3. So what is f of 3? You need 3f of 3, right? You find this point, 3f of 3. So 3f of 3 is this point. That's 3f of 3, so this is 1, right? 3, 1, right? 3, 1. And then to find g of 3, so you need 3g of 3. This point on the graph of g. So where is this point? It's 3, 0, right? It's 3, 0. Okay? Yeah. So f of 3 is 1, g of 3 is 0. So this is 1 times 0 is 0, right? It's 0. Okay? Yeah. So now this one is f of 1 over g of 1. So now this time we need to find f1 and g1, right? f1, g1 on the picture. So f of 1, so we need 1, f of 1. And then g1 we need 1, g of 1. Okay, so 1 f of 1. So where's 1 f of 1? This point, right? So it's 1 is 3, so this is 3. And 1 g of 1. So where is 1 g of 1? So it's here. It's 1 -4, right? 1 -4. So this is -4. Okay? So this is 1 goes to 3, and then g is -4. So this is 3 over -4. Right? 3 over -4. Okay, yeah, so that's the structure of the point, right, of the point. Okay, yeah. So now the next point is f compose f of 1, right? So let's do it here. So this is 1, and then we need to know where is f of 1, and then where is f again sent to that point, right? F of 1 we already know is 3, right? It's 3. Okay, and then f of 3. So we already did it here in the question 14. So f of 3, we are looking at this point, right? 3f of 3. So it's 3, 1. So it's sent back to 1. So this composition is 1 to 3 and then 3 to 1. Okay, 3 to 1. So this one, f compose g of 3, right? So this is 3, and then we first go g, and then we go f. Right, we go f. So what is g of 3? So we do it again. It's 3g of 3, right? So this will be 3, 0, this point, right, this point. So g of 3 is 0, then we got a 0 here, and then we got f of 0, so we need 0, f of 0. So what is f of 0? F of 0 is 4, right? This is 0, f of 0 is 4, so we got this is 4. Okay, this is 4. Okay, yeah, so this is for the composition, right, for the composition. Okay, so now for the inverse function, right, for the inverse function, how to find f negative inverse 4, right, f inverse 4, okay, yeah. So now let's draw the picture again, right, so it's x send to 4, this is f, and then f inverse send it back to x, right, send it back to x. So now which point is on the graph? So this is x comma 4 on the graph, right? So input and output, they're on the graph. So x4 is on the graph, so which one is x4? This one, right? This one. So x is 0. Okay, x 0. So f send 0 to 4, and then f inverse send 4 back to 0, right? 4 back to 0. So this structure, this picture is important, right? It's important. So f inverse 4 is 0. Right, is 0. So now let's do it again, because this is f inverse of 1, right? F inverse of 1. So f inverse of 1, f inverse of 1, so with the x send to 1 by f, and then f inverse send 1 back to x, right? So which point is on the picture? These two, right? x1 is on the picture. Right, x1 is on the picture. So now you look at height 1, so this is right, height 1. Okay, so this point is x comma 1, right, comma 1. Okay, yeah, so x comma 1, so this is 3, 1, right, 3, 1, so x is 3. Okay, 3, 1. So f sends 3 to 1, and f inverse send 1 back to 3, right, back to 3. So this is 3. Okay, this is 3. So f inverse is a little bit harder, right, a little bit harder. Okay, yeah. Okay, so that's it. That's all the review questions.